running a DC locomotive from JMRI using Arduino as a decoder. Can it be done? Let's have a look and see.
This is where I got most of my inspiration from. I've always been interested in automating model trains, using Arduinos mainly. But it wasn't until I found Hi's channel, the H&H Express Model N scale trains, that I'd considered linking DC Locos on a railway up to JMRI and controlling them as though they were DCC. Now, Hi's got an extensive channel here with all sorts of hints and tips and things. But he does go into the detail of the system that he's developed so that he can run DC locomotives as though they were DCC, essentially. This is a really useful channel. I would suggest that you go and have a look at it. There's lots of useful information on it. Here's the basic setup that I'm using. I've got 3 Arduinos and one L298N motor driver. The first Arduino is connected via USB to my laptop, and it works as a DCC-EX command station. So it gives me the interface up to JMRI. The other 2 are configured as DCC decoders. Now, because I'm using DC Locos only, I really only can control the speed and direction of the loco from the decoders. The DCC-EX sends all the commands to both decoders in parallel, and they need to sort out which messages are for them and ignore the rest, the same as any standard DCC system. The LN298N motor driver module can drive 2 separate motors, or in this case, 2 separate tracks. So I can use decoder 1 to control track 1, decoder 2 to control track 2. There are 3 lines from each Arduino decoder to the motor driver. One which gives the PWM signal, or pulse width modulation signal, which controls the speed of the loco, and 2 others which determine the direction of travel of the loco.
To stop the diagram getting too cluttered, I've left off the power supply lines. The DCC-EX command station gets its 5 volts from the USB connection to the computer. I've jumpered together the 5 volt line from it to the other 2 decoders and down to the motor controller. There's a 5 volt input here. Similarly, there's a ground connection here which needs to be made to the 0 volt or ground connections on each of the Arduinos. They all need to be daisy chained together. in order to provide the actual power itself for the track, there's a 12-volt input and ground pin on the motor controller. While we're on the motor controller, because we're providing an external 5-volt line, this jumper needs to be removed. Otherwise, it'll try to derive an internal 5 volts from the 12-volt line, which is not what we want, really. When we get to the DCC signal itself from the command station, in normal use for a DCC-EX command station, that would be connected through a motor shield on the station to provide the 14 volts output to the standard DCC decoders on the tracks themselves. But in this case, we're just using the 5-volt signal from the Arduino itself directly into the 2 inputs of the other Arduinos. If you put a DCC level 14-volt signal into an Arduino, you'll blow it up. So don't do that. Okay, so let's control a DC locomotive from JMRI. Here's my DC Flying Scotsman. And let's run her from JMRI. You may be able to see that it's gradually increasing in speed through momentum. When we reach full speed, let's slam her into reverse. So again, the momentum control gradually slows her down to a stop. Gradually. But once it's stopped, it'll change direction and carry off in reverse. Similarly, if I want to change direction again, we slow down. And away we go and forward. The other feature that I've implemented is the emergency stop. But why stop at one Flying Scotsman when you can have 2? These are each connected to one side of the L298N motor controller. And I can control them separately. So here we are from JMRI. I can control loco number 1. And I can control loco number 15, which has been configured with slightly different CVs. So it takes a bit longer to get up to speed. But again, it's got the same functionality I can select reverse and it will slow down and reverse, etc. Now, the other thing I can do we can run a script. We can run local 1 for a bit. And local 15. Or run them both together. And as they're both configured with slightly different CVs, they take longer to start, they take longer to stop, etc. So far what I've done is I've got JMRI controlling the 2 locomotives. What I haven't got are any inputs from the sensors of the rail system. So that's my next little job, is to add detection sensors. And here we have the actual setup itself. The wiring's obviously a bit of a mess, but I'm running 2 locomotives from the Arduino UNOs. Everything's powered from this old Maplin 12-volt power supply, or USB from the laptop. I didn't mention it earlier, but you can see I've got I've got 2 JMRI throttles up, and I can control the locomotives independently. Not sure how well that shows up on this, but I'm sure you get the idea. So finally, I'd like to say something about the software that I wrote. It's currently a work in progress, so I'm not going to release it just yet. I have a few more additions to make to it, and I've got a load of testing to do, and a lot of tidying up as well. However, it is based upon DCC Inspector, which is a DCC packet protocol analyzer, and that allows me to identify the various commands from the DCC command station that I'm interested in, and ignore the rest. And also fast PWM pin, which is an Arduino package which allows me to run the PWM at a much higher bit rate than I can actually hear. So I tried using a 50 Hertz PWM signal to start with, and that gave an annoying buzz when the locomotives weren't quite moving. So I've increased the rate of the PWM to 20 kilohertz, which I used to be able to hear when I was a kid, but I can no longer hear. The software supports the following 5 CVs hard-coded into the Arduino. Primary address CV1. That's normally the address of the locomotive. In our case, it's the address of the track that's being controlled. CVs 2 and 5 are V start and V high, which are the lower and upper speed limits to be applied to the track. And CVs 3 and 4 give the acceleration and deceleration rates used to simulate momentum on starting and stopping a locomotive. I might have a go later on at adding CV65, which is the kickstart, which is a higher than normal value, which is applied to get a stopped locomotive moving in the first place. Now, one of the limitations of this system is that normally these CVs would be tuned to the locomotive, whereas we're simply applying them to a track. And obviously the values that you might choose for an 040 would be completely different to those for an 010-2 or whatever. So we need to choose fairly generic values for these. What I intend to do next, I want to add some infrared sensors. So I'll need to add a node to the system to enable those to be fed back to JMRI. I'll also need to build a layout. For various reasons, I don't have one. But I'll need a layout, or at least a test track somewhere so I can test these things out properly. As I said, I would like to add CV65. And one of the big limitations at the moment is that we're hard coding CVs into the software. What I would very much like to do is to do on-track programming of CVs. Also, sounds, well, I'm not a great fan of sounds, but yeah, it would be nice to have some around there. Again, this is a major limitation of this system in that we're controlling a track rather than the locus. So any sounds that are generated will be generated in a single position on the track. You know, and the whistle of a locomotive will not follow the locomotive around the track, but that's just a limitation of where we are. And finally, it would not be too difficult to modify the loco decoder to be an accessory decoder. So thank you for watching. If you've got this far, thank you very much. And I hope to get back to you soon with a bit more progress. All the best. Bye.